Oh, that doesn't do the way I want it to do. Okay, so I'm going to give a talk on the composable architecture. Yep, you can record my screen. The composable architecture was developed, I don't know, I think Josh was saying about over 2 years ago. I recently got into it about a year ago, but it was developed by Point Free, and it's intended to be an opinionated library of building applications in a very consistent and just understandable way. And pretty much understandable way just kind of leans on the consistent. If everything's built the same, then you'll expect, how it's built. I might say it as TCA, that is its very short acronym. And TCA has a focus on composition, testing, and ergonomics. It is composable in the sense that you can have multiple different views and they can be isolated on their own components. They could even be in their own Swift modules, in their own repos, and they don't even know each other exists, but they can be composed in such a way that the parents and childs just kind of link together if they have the data state that a view or whatever expects. It's a unilateral state management, which means that you can only send actions, and then the state and everything will be modified. That means that you can only actually read the state, and you can't actually directly modify the state. And then it comes with the ability to handle side effects. And now side effects are kind of a unique term. They really just mean anything that's asynchronous. Everything in TCA is ran on the main thread, except for side effects. Side effects are handled in some background thread. And then when they are finished or whatever is done, they come back into TCA, into the kind of system, and they're fed back into the system so they can be handled on the main thread. So let's say if we fetch an API, well, the response will come back on the main thread and it will update everything accordingly. And as I said before, this was developed by Point Free. So quickly, if we just get into the basics of the types and values that you'll be using, I'll just kind of say the name and then we can, I'll just say kind of what you'll be using and then we can dive into it a little bit more. And I have an example later. So what am I going to use? Well, the main few things that you'll use is obviously state. Every object will have its own state, which it will need for either displaying UI, like a label, or processing data, like is it loading, or is something locked, or is it, stuff like that, where it might not be shown on the UI, but it's with the logic of how the UI is displayed. The actions, and this is all possible actions a view or an object can perform. So if we think of a login view, we can think of, well, I can log in, I can log out, and I can, do some other stuff. And that's a bad example because I only said two, but really it's the culmination of every single possible modification of state. So if a state or if the state object can change for this view, well, we'll need an action that drives that state. Like I said before, it's unilateral direction of data flow. So we need these actions to drive our state because we can't modify the state directly. After that, we have this optional environment. And the environment is thought of as kind of like this black box. So not everything will have an environment because not everything's, reaching out into the outside world. Let's say you had an API call. Well, you might want an environment and you might want that environment to know how to make that API call. And in that way, you can mock it out or you can make this live implementation. So let's say I want to hit Wolfram Alpha for my live API call, but when I'm mocking it out, I actually just want to return a value. You can do that with the environment. It makes it very easy. The most complex kind of object in TCA, and where I think a lot of people, there's other issues with TCA, but I think this is one of the first things that people have an issue with, is understanding the reducer or just liking the reducer. It's either one of those. But pretty much the reducer is something that takes in an action and modifies the state according to how it should modify it based off that action. So that's pretty simple. We'll get into it a little bit more because it is one of the bigger topics of TCA. And then the last kind of object we'll talk about is really an object that we never need to implement on our own. We just need to give it some generic types and then we can create and use it. So the state object is, or the store object is really what drives this whole interaction of state and action and potentially an environment. So what is state? I mean, I think we all know what state is, but really kind of diving into it, state is just data. It's either required data, it's view data, extra data, or like Josh was saying before, it's just our children data that we don't really care about. So pros and cons to that, but ideally on the right, you'll just see that state is a struct, and it can optionally conform to equatable so that we can know if a state is equal to another state. There's also a little note down here. State can actually be any type of data. It doesn't have to be the struct that I defined over here. It could just be an int. I have a counter example, which it just counts an integer up and down. And right now it is using a state. And when we look into it after this, I'll show that it could just be an int, because really that's all the values it cares about. So an action is simply just an enum. It's just every single case that you can do. If a user can press a button to add a new to-do item or add something, well, that would be a user action, and we would have to add that action to our enum of actions. But let's say that we have this API call. This user presses a button and it happens to fire this API call. Well, we'll need an action response to finally feed that back into the store. As I was saying before, effects are handled in the background, but they need to be fed back into this reducer with this action so that we can update everything on the main thread. And again, like Josh said, with state comes actions. So obviously we'll need child actions because if we compose everything together, the parent of these children will need to know the children's state, but it'll also need to know all the children's actions, even if it is just passing them through to the child. And this is also another kind of nice thing. If we do have a parent that observes child actions, maybe we want to just fire off analytic calls for those children actions. So a child never has to actually worry about analytics, but then its parent can log any analytical event it wants. So that there's pros and cons to it. And finally, what is an environment? Now, an environment's kind of a black box. It's really just tell me how to do this and I'll give you this. Ideally, it's just a ton of closures where I give it this ID and it just this user and returns a user. So it's pretty simple like that, but it's mainly used so that we can have mockable dependencies or closures, making it very easy for us to write tests and be able to mock out our environment so that we don't care about the outside world and those don't affect our tests. We want to just make sure that our logic makes sense and that we can, well, if our logic makes sense, then then we can test the outside world and make sure that things are working. The only other thing that the environment will need, it'll need to know the main scheduler queue so that it can update on that main queue. And that's kind of specific to how it works. Just because effects are kind of done in the background, they come back on, and then the environment knows which queue to update them on with the main queue. Potentially for actually doing iOS, you'd want to do the main queue, but this is kind of open. So it could be a test scheduler that I actually control when it advances. So if I have this API call that, in normal takes maybe 30 seconds or, something long like that, I guess, I don't know, 5 seconds or less, I can actually just use a test scheduler to advance and go forward instead of actually waiting 5 seconds. So that's pretty nice. So what is a reducer? I've said some things about a reducer, and like I said, not too many people like it. Some people like it. I don't know. It's okay. But a reducer is the culmination of a state, action, and environment. And more specifically, it looks like this. So we have a reducer. We pass in generic types. We need to pass in a generic state type, action type, and environment type. And then it can really drive off of that. A reducer just defines the state for any given action. If I say, if I have this reducer for a login and I say, hey, the action is login, well, then it's going to start the login process. It's probably going to, hit an API. And then at the end, it's going to feed in and say, I've logged in, or, there's an error. Reducers use state, action, and they also use environment. The environment's kind of that, hey, I can't really do this directly. I need to reach out and have this done for me. And the reducer really just is given an action, a single action, and we just switch over that and we modify the state accordingly. But if we can't do it, then we just call out to the environment and then have that do the rest of the work. Finally, the reducer is fully 100% testable business logic, or should be. If you're not, or if you can't test the reducer, then you're probably not doing it correctly. Ideally, you can create the state, action, environment, and then you can create the reducer. And after that, you have full testable business logic that you can write tests on even before you get to the view. So it's really nice that it kind of does that. Really, there's not going to be any external business logic, except maybe if you're doing something in a view and that happens to change and send an action to the store. But most things where state changes will happen in the reducer. And again, kind of talking similar, we've said state, action, and environment are all in reducer. And then there is a reducer for a store. And I've talked about the store object, and this is really an object that we just send actions to, and we can read the state. That's pretty much it. There's some fancy other stuff for being like, hey, I want to get a binding or I want to scope to a certain variable. Again, I'm going to pick on Josh. Like Josh was saying, if a view has children data, it can scope to that data and send it down. And pretty much the child view will only know what it needs to know. And you'll just kind of see this pattern over and over again, is a store can produce a scope into a store, which is very limited in its scope. It might not know everything, but the child, that is the object that it accepts. So you're pretty much always making stores for these objects. And I'll get into a little bit later, but ideally you can create two different stores. You can create a store for the view, or you can create this test store and you can write a full XC test case on it. So if you're looking at views, you're going to be expecting kind of this just generic store. And then an XC test case, you'll use a test store. So these are just kind of what you'd expect to see, is that we'll expect to see a state, action, environment, some reducer, and then a view will need a store, or an XC test case will need a store. So let's look into a little project that I have. It's just a counter app, so it shouldn't be anything too difficult, but we can check out, I'll just run it really quick. So I'll just demo it really quick so we all know kind of what happens and we don't have to dig through the code to figure it out. But ideally, we're just going to have a counter that counts up and counts down. There's no extra logic to that. It doesn't stop at 0. It doesn't do whatever. Hopefully it loads. Okay, there it is. Okay. And so we can just press these buttons and it's going to count up and down. And every time I press this button, it's going to send an action to the store. And this value right here is just reading the current count from that store. So let's look into that. First, we have a state. And please tell me, I'll just make it bigger without anyone telling me. I hope you can see it. So first we have a state. And the state, like I said before, is really just a count, and it's just an integer. That's really it. And then for action, I can only increment and decrement. So when I press the increment button, it goes up. When I press the minus button, it decrements. So easy enough. Now, looking at the reducer, we said before, and I'm going to take a step back to kind of look at the syntax, because this is really just an object that people kind of look at and it's like, what's happening? So a reducer has a state that we can modify. It has an action that it expects. So we know all of the actions coming in are going to be this counter action. And then we don't have an environment. So we just say it's void, because we really don't care. There's nothing that we're fetching to an API to be like, whatever, we're just incrementing and decrementing, and that happens very quickly. So we'll just look at the action that comes in. And this is a state object that we are able to modify. So we can do anything to the store or the state. We could say count is 45. That's not correct. And obviously, when you're defining your business logic wherever it is, it needs to be correct. So obviously that doesn't make sense. So when we decrement, we'll just have -1 to the state or the count. And then if we increment, we'll just have +1. Now, I'll call out this return none. And this is kind of an interesting thing. And I've been saying effects. An effect is something that can happen after an action. If I press login, well, let's say, for example, I'll just write some dummy code so none of this is going to work. Let's say if I press the action of login, well, I could say that I'm is logging in. Let me just set that to true. But every action can possibly have an effect. So at the end, we would return if it has no effect is .none. So everything in here right now doesn't have an effect. But let's say if we wanted to fire off another effect of something, well, we could just kind of, oops, sorry, I'm clicking on everything wrong. We can just send in another effect. And you can see from here, I actually can only send in the effects that we currently have. So I could send in that when you increment, it would just then decrement. But this is how actions can produce effects, and then how it kind of goes through the whole thing. So maybe there's 3 actions and effects that happen because the user pressed a button. So that's specifically what the .none is. It's just this doesn't produce any effects, so it's not going to get fed back into the system. Finally, we actually get to the views. But I will note that, as I said before, we can fully test after we have the reducer. We're just going to use a test store. So I have tests for this, and this says full counter reducer. I changed the name. So we'll just change this. That's good. Okay, so we have this test store. I set it with an initial state of just 0. So it starts with 0. And then I pass it in the counter reducer because that's the logic. And then now I can send events to the store. So like we know, our actions are increment or decrement. So when I do send increment, I would then expect the count to be 1. When I send another increment, I would expect the count to be 2. And then finally, when I decrement, I expect it to be 1. Now, this is an interesting syntax right here, but this closure is just the expected evolution of state. So let's say if our state had multiple values in it, maybe multiple things change, and not just one value. So if multiple things change, well, I need to define or modify this state object to whatever it's expected. So if we start at 0 and I increment, we would expect it to be 1. But what about if I put 0? I mean, just making sure this works, right? Well, it should fail, and it should say some pretty nice output for exactly what's happening. So state change does not match expectation. And our expectation was count 0, but it actually says it's 1. So it's pretty nice. If we have multiple things that's wrong, then really the state is wrong. It's not multiple of these values. So it's really nice how it kind of pops that into one message, and it's like, no, the state is actually this. So there it is tested. We can run that and make sure it works. And then going back to here, you can see I do have test coverage on here, so you can see that it is running these, and it is running the full reducer. So we can know it actually works, and it works expected. So now we can go to the view, and we can create this counter view. And the first thing that we're going to create for a view is some store, and this store has our counter state and our counter action. Pretty much in here, we're going to use this with view store, and this with view store is just very specifically with SwiftUI. So store itself is not an observable object, but once I have this inside of here, view store becomes this observable object that I can actually observe and read and view. And right here, I just view the count. So that's easy enough. And that's why that updates. And then I just have these buttons, and I have the H stack where the buttons are. If you don't remember, see, there's an H stack with buttons, I promise. And then the buttons just send actions to the view store, and that's all they do. So it's really easy to see, hey, where are all my actions, or how is state being modified? Well, it's either in the reducer or it's actions sent to the reducer. So I can quickly see that it can only change the state because it's sending these two. And then finally, the intro app right here for when it's actually created is very similar to how we create that test store. We give it an initial state, we give it a reducer and an environment. Last thing I'll just go over really quick is we can remove the state, as I said before, and the state doesn't actually need to be this object. It could just be an int, because technically that's what's happening, is that we are only modifying an int. So if I quickly just change everything to int, and just change this to state, well, it's going to fail because right now we'll just put it in 0, and we'll just put it in 0. So now this whole view and the reducer are working on a single value, and that is literally just an integer. So if I build it, it will work exactly the same because everything's being provided to it. It's just a single integer that I'm talking about now. And there, it still works, just being an integer. So this value right here is literally just an integer. It is not like some state object. I mean, technically it is still the state object in the store, but yeah. So last thing I'll note on is why this is cool is because you can have reducers for huge objects that then have child reducers, or a reducer could literally just be on one value. It could be on a string, it could be on anything like that. And it's just the flexibility that then now this one value has these actions for how it's modified. So we have a little protection and unilateral data flow for that. So, but that's it. Is there any questions? I'll open up to questions or anything like that.
Did you say that, I mean, was there only possible to do one effect per reducer? Is that, or is it possible to do multiple effects per reducer, or does doing multiple effects per reducer not make sense for Redux? Because
So I
return type is the effect, right? So like you can only have one return type, right?
You can have one return per case.
Yeah, and it looks like you can potentially concatenate them, but ideally, yes, you need to return one effect per case or just one effect. And then that effect could do a cascade of other effects.
Cool. So it looks to me like it's largely unchanged from the last time I looked at it. I don't see any support for any of the new Swift 5.5 features, specifically async await. Like it doesn't look like you can actually use an async stream or an asynchronous function as one of the effects. And then also, I don't see any support for actors. Like it's still using the manual threading.
Yeah, I think they were starting to add async await, but like I see the a PR for it. So potentially at some point they'll be starting to add those and that stuff, but I just looked into those recently at work. So yeah, I just learned about them, but that'd be cool. But maybe, I don't know. Kind of surprised that they don't have that, but yeah, I mean, at that point that they do have async await, they could just get rid of the whole idea of an effect and then just have an asynchronous function. And I think that would clean it up a lot more.
Well, I think you have to offer both because async await doesn't have a lot of the functions that combine does have. So things like throttle and debounce and all that kind of stuff are still missing from async stream.
Yeah, and that's a really good point. Is pretty much an effect in this case is just their kind of opinionated wrapper on like an any publisher or publisher. So it's very combined specific in this case right now. So yeah, like you said, they're going to need to offer both, but they provide it in a way that they're like, this effect thing could be implemented in any way, but it's kind of just more opinionated than what they said at the beginning, I feel. Cool. Well, I'll just hand it over to you, David, or we can take a little break.
Thanks, Zach.